In this video, we're going to do some guided exam question practice on the 2013 exam question that came up on radioactivity. So it was what, 25 marks. Okay, so see there, 25 marks. So if you add them all up, 25, and that gives you a total of 10 minutes. Okay, so get your timer set for 10 minutes. Okay, so we're going to start reading the question. All right, so let's break it up. It says cesium-137. Okay, so cesium-137 is a radioactive isotope of an alkali metal called cesium. Okay, so this is cesium-137, the radioactive isotope. Cesium-137 was released into the atmosphere when the Japanese nuclear reactors were damaged by a tsunami in 2011. Now notice they often do lots of these things, put these type of pieces of information into questions just to make the question relevant, but the information in there isn't really that important. There's nothing in there it's just out of interest, I suppose. It's not what's important. The next bit, though, is important. It says cesium-137 decays by beta particle emission with a half-life of 30 days. So both of those things are definitely going to be important. So cesium-137, beta particle emission, half-life of 30 days. Right, let's get into the actual questions. What does it want us to do? The first thing says to define radioactivity. So define basically means to write a description or an explanation. Okay, so what we're doing here is radioactivity. Okay, so again, from memory, if possible, pause the video now and write the definition of what radioactivity is. Do that now. Okay, so it should only be plain if you have written a definition for radioactivity. I'm going to get you started on this now, so we're going to correct it. And if you didn't get a chance, if you didn't know it, then hopefully this might trigger your memory. So radioactivity is the spontaneous, and what spontaneous means is really this happens completely randomly. It's not timed, it just happens automatically by itself. You can't predict when it's going to happen, and it doesn't need any help. It just does it, spontaneous. Okay, so it's the spontaneous breakup something. So again, if you didn't get anything the first time, pause the video, try and finish it. Okay, well, it's a spontaneous breakup of an unstable nucleus. So some nuclei are unstable. Of an unstable nucleus with the emission of one or more types of radiation. That's what radioactivity is, more types of radiation. Okay, so some elements are unstable, some nuclei are unstable, they will break up eventually, and radiation is given out. Okay, so this is what you should have. Right, let's look at the second bit. Give two differences between chemical reactions and nuclear reactions. Okay, so this is part 2. So this was part 1, sorry. This is part 2. It's handy here to use a table because we're asked to give differences, so we'll compare it. We'll use a table, and we're going to compare chemical reactions with physical reactions or physical changes. Sorry, not physical, no, nuclear. Apologies, that's my lack of attention. This is nuclear reactions. All right, so pause the video and write down, compare them, two differences between them. Okay, so pause the video, do that now. Okay, so hopefully we got at least 2 of these. Okay, the first one we're going to talk about is, well, what do they involve? Which part of the atom do they involve? So if you didn't talk about which part of the atom they involve, go ahead, pause the video and write that down now. Okay, so hopefully it's obvious that a nuclear reaction involves, well, it's nuclear, so it involves a nucleus. It's a nucleus. Whereas chemical reactions don't involve any change to the nucleus. What part do they involve? They involve the orbiting electrons. So these electrons that are in the shells or the energy levels, these are what's involved in a chemical reaction. So these involve the orbiting electrons. That's one difference. The second difference I wanted to talk about is which one creates a new element. So if you didn't already talk about that, one of these reactions always creates, or not always, but sometimes creates a new element, whereas the other one does not. So pause the video and write those down now. Okay, so it should only be plain if you've talked about which ones create new elements. Chemical reactions, they do not create new elements. Do not create new elements. Whereas nuclear reactions often involve changing one element into another. So these ones do create new elements. So those might have been the two that you had. They were well done if you had them by yourself. All right. Another one that we could have said here is which one releases nuclear energy. So once the reaction happens, it releases nuclear energy. Well, that's obviously going to be nuclear reactions. So these release nuclear energy. And these ones do not release nuclear energy because there's no change to the nucleus. Okay. All right, so hopefully you've got at least two of those differences. A reminder that when you're talking about difference, you should have both. You should explain it on both the chemical reaction and the nuclear reaction side. Okay, so these are matches. That's one difference. So this here shows only one difference, even though we've written two things. And then this is a second difference, this whole thing. Okay, so you don't have to use a table. You could write it out as a sentence. But if you're writing out as a sentence, you must talk about both types of reactions. So you must say chemical reactions involve orbiting electrons, whereas nuclear reactions involve the nucleus. That would only be one difference. Okay, so hopefully that's clear. All right, the next one, give two properties of beta particles. So make sure we're given two, and we're talking about beta particles. Okay, so over here, part 3 we're looking at. Part 3. Okay, so we're talking about beta particles. And again, some of you will know exactly two properties of beta particles. If you do, pause the video and write them down now. Okay, if you didn't know two properties of beta particles, I can maybe give you a hint. If we know what beta particles are. So hopefully you remember what they are. Okay, beta particles are fast moving electrons. That's what a beta particle is, electrons. Okay, so now that I've reminded you of that, now thinking about what are they fast moving electrons, now can you give two properties of them? Okay, now my suggestion here is if you can give three, try and give three. Pause the video and write down three properties of beta particles, which are fast moving electrons. Okay, so hopefully you have done that now. Okay, so what do we know about them? Well, they are electrons. So what charge would they have? If you didn't get this already, pause the video and write it down. Okay, so they have a negative charge. That's one of its properties of a beta particle, negatively charged. Okay, what else? What about the mass? Well, we've already learned about electrons for sure. What type of mass do they have? What size is it? Or is there a word that describes its mass? Pause the video and write down about the mass of a beta particle. Do that now. Okay, so beta particles, because they're the same as electrons, have what we call a negligible mass. Negligible mass. Okay, or it's actually 1/1838 AMUs, if you were to give it a number. Okay, but negligible mass is fine. A third difference, well, think about the other part. What would you say if we said it's fast moving? If a beta particle is fast moving, what would a property of it be? Pause the video, write it down. Okay, so we could say beta particles have a high speed or high velocity. Okay, all those three things are of beta particles. Now, there's lots of other things as well, which we'll see in the marking scheme. So if you had a couple of different things, we can check. When we check the marking scheme, some of them might be right. Next bit, and this is definitely the hardest bit in this question. It says a certain mass, so it's not telling us how much, it's just a certain mass of cesium leaked on a particular day. What fraction of this mass remained as cesium-137 after 90 days? Okay, so the first thing that's in my head is how many days have passed, 90 days. Now I'm going back up to my question to see was there any information about days. Look what it says here, half-life is 30 days. Okay, so 90 days, how many half-lives is that? Write down how many half-lives is that have passed in 90 days. Pause the video and write that down now. Okay, so that hopefully is ringing a bell that this is 3 half-lives. Okay, 90 days is 3 half-lives. So down here, we're doing part 4. And it says, after 90 days, what fraction of the nuclei remain? The first thing to note is 1 half-life equals 30 days. 30 days. Therefore, 90 days, well, that's 3 times 30. So that will be 3 times 1 half-life, which is 3 half-lives. Okay. All right. So we're saying a certain amount. We had a certain amount of a certain mass. Okay. So we don't know how much that is, but what we're asked is what fraction of this mass remained as cesium. Okay. So let's assign, let's just say the mass was 1 kg. Doesn't really matter how much it was, but just say it was 1. Okay. You can put any number here, but what we need to do is find out how, after 90 days, how much is going to be left. Okay. So let's say we start with 1 kilogram, assign a mass of 1. And after 1 half-life, what happens to the mass is, well, there will be half the mass left at the end. Okay, so that means 1 is essentially turned into half of that mass by the end. Okay, so what I want you to do is pause the video and finish this off for 3 half-lives. Do that now. Pause the video and do that now. Okay, so hopefully you said, okay, so after the second half-life, half and a half. So if you take half a pizza and you half the pizza again, how much pizza do you have? Well, half times a half is going to be a quarter. And again, if you're ever stuck with that, you can always do it on the calculator, half times a half. Okay, now what we're doing is that's only 2 half-lives. We said we needed 3. So what we need to do is, if you didn't finish this off, pause the video, finish it off now. Okay, so let's do the third half-life. So we're timesing it by a half again. So the amount of mass has halved again. And if you're not sure on fractions, multiplying fractions, get your calculator out, do a quarter times a half. What you're going to get is 1/8. Okay, and this is your final answer. So 1/8 of the mass was left after 1, 2, 3 half-lives. This is how you would do this question. All right, so that's us done. Pause your timer. Hopefully we didn't go over the 10 minutes. What we're going to do now is we're going to take our marking scheme and we're going to go ahead and we're going to mark it. Okay, so let's check our work. The first thing you're asked to do is to define radioactivity. Now I've given you the definition. Let's just check. Spontaneous is in bold. That means you have to have it, and we have it. Spontaneous decay or breakup or disintegration. There, look, breaking up. Okay, break up of. And nucleus is a key word here, unstable nucleus. So, and then releasing, and then it's given specific types of radiation, alpha, beta, gamma, but that's not in bold. It doesn't have to be said like that. We have said with the emission of 1 or more types of radiation. So that's fine. Okay, so this was what, 6 marks. So we're getting our 6 mark there. All right, let's look at the next one. Give 2 differences. Okay, so let's look at what we have. We've said give 1 way. Chemical involves electrons, whereas nuclear involves nuclear change or change to the nucleus. Okay, so that's 1 difference, and it's 2 by 3. So this is 3 for this one. What else does it say here? New elements. Okay, it'll create new elements. So that's nuclear reaction is new elements, and then chemical reactions, elements unchanged or no new elements. Okay, so there's our second one. And then what the last one, we can only get 6 here. So we've already got 6, so we're not getting any marks for this, but would this have been right? Nuclear reactions release nuclear energy. Doesn't actually say nuclear energy. It just says energy. But energy comes from mass, would be, I think you would get that in the exam. Okay, oh no, sorry, it does say, it says, sorry, release of nuclear energy from nucleus. Release of energy from nucleus. So that's that one. And this one says no release of nuclear energy. Okay, as you can see there. So marking schemes can be quite complicated, but you're looking to see if you've got, you know, if you've got the key points that are in there. All right, let's look at the next bit. 2 properties of beta particles. Okay, so negative, as you can see here, negatively charged. There's 1, and again, it's 2 by 3. So there's 3 marks. And what else do we have? Negligible mass. So we've got the first 2, okay? High speed would have also been correct. Look at it here, and look at, there's lots of other things. So pause the video and see if any of these are what you have talked about. Look at, you've got penetrating power, you've got ionizing power, all of those things. You've got, they're deflected by electric fields. Okay, so again, just pause the video. If you didn't have the 2 that I had, and you had different ones, pause the video and see whether you would have got the mark or not. Okay, and then here, the last one for 7 marks, you asked what fraction, and you should have got 1/8. That's what we got, and that was worth 7. So that's all the marks, 25 out of 25. Hopefully you can see that's not a bad question, I don't think, for radioactivity, so long as you know your stuff. Pretty straightforward. The last bit, a little bit tricky, but you know, it's at the end of the day, it's just multiplying fractions. That's really all you have to do. So the maths there isn't very difficult. All right, we'll see you in the next one.